Okay everyone, welcome to Word Problems, the applications of all of the sinusoidal curves. So if you remember in an earlier video, I had mentioned that sound is all sine waves, and we can talk about sunrise and sunset. Those actually are sine waves. Tidal waves are all sine waves. So today we're going to talk about two things. One's a Ferris wheel and the other is a rocket ship. Before you start, you should have graph paper, you need your calculator, and then I would use my book to follow along. And of course, ruler never hurts. So get those things and we'll get started. So number one deals with the Ferris wheel. And I'm just going to read through it. As you ride the Ferris wheel, your distance from the ground varies sinusoidally. I like that word, with time. When the last seat is filled and the Ferris wheel starts, your seat is at the position shown in the figure, which we'll look at in a minute. T is the number of seconds that have elapsed since this Ferris wheel started. You find that it takes you 3 seconds to reach the top. So I'm just going to kind of graph this as we go along. Okay, so I get on the Ferris wheel, and at 3 seconds, I reach the top. So let's just say that's here. And you should make sure you label your axes. This is time in seconds, and this is height in feet. And we are told that it takes you 3 seconds to reach the top, which is 43 feet above the ground. How about right there? The wheel makes a revolution once every 8 seconds. So if I start at 3 seconds and it takes me 8 seconds to get back up to the top, that would be 11. So 3 plus 8 is 11. So halfway in between there is 7. Another wonderful Miss Babiak curve. So this is great, but it's not enough information. So I know the period is 8, so let's just write down what we know so far. Period's 8, and that's going to help me find B. And then the biggest piece of information that we have yet to apply is that the diameter of the wheel is 40 feet. The diameter of the wheel is 40 feet. So if 43 feet is my high point and the diameter of the wheel is 40 feet, that takes me down to 3 feet. So my sinusoidal axis is somewhere in between. This is not the greatest of graphs. So my amplitude is going to be 20. The diameter of the Ferris wheel is 40, so that's the quote-unquote height of the wheel. And then half of 40 is 20. And if you recall, that's how we find the amplitude. So this is going to be 23. The sinusoidal is not 20. The amplitude is 20. So my amplitude is 20. And my sinusoidal is at 23. And we're going to say H equals 23. Okay, so from here I can almost write my equation. And I know we're not asked to write the equation until later on in the problem, but I want to write the equation now just because I just think it's easier to do it now. So if you look, this cosine curve has been shifted right 3 units. This curve has been shifted right 3 units. So here we go. Should you use radians or should you use degrees? For word problems, you are almost exclusively going to be in radians. Almost exclusively. So I will show you how to convert your calculator to radians in just a minute. Let's write the equation of this graph. Y equals. It is shifted up 23. It is a positive cosine curve. The amplitude is 20. We know that it has been shifted write 3. So there's my theta minus 3. Get used to using theta. I know, it's unusual right now, but you'll get used to it. We use theta almost exclusively for angle measures. Just like I said earlier, we use radians almost exclusively for word problems. So if the period is 8 and I want to use radians, that means that 2 pi over b is equal to 8. Solve for b, and I believe you get pi over 4. Okay, so you'll notice, I think this is part B. Part B asks, why is the lowest you go 3 feet? Or what is the lowest you go and why is it more than 0? So the lowest you're gonna go, if you noticed right here, is 3 feet. The graph, its low point is 3. It never goes below. It never hits 2, it never hits 1. So the question is, why is the low point 3 feet and not 0? So pause, think about the answer to that. So the reason why it never hits 0 is because that would mean the Ferris wheel itself, the actual wheel, so you have this wheel, it can't be on the ground, right? How can the wheel itself actually hit the ground? Well, I mean, it could, but it would be damaged and no one would want to go on that Ferris wheel. Calculator, let's convert radians to degrees. So let me clear out here. Okay, hopefully you can see that. So mode, which is next to the second key, mode. Your calculator is probably defaulted to radians. So if you look at the third line, so if you down arrow and see my cursor is flashing on radians, you are likely in radians. It's the calculator default. I'm not, because I was doing a problem in a different class, so I was in degrees. So if you hit enter, radians. If you go to the right and the degrees is flashing and you push enter, now you're in degrees. So we are going to be in radians for right now, because like I said, for the 14th time, if you are doing a word problem, most likely radians. So the rest of this is primarily a plug and chug. So I'm going to help you with a calculator for the first one, and I think that you can figure out after that. So I'm going to do part D, number 1. Or actually, I think it's I. So T is 6. Okay, so you need to make sure that you are getting the proper answer. This is 100% just utilizing your calculator. Okay. So I would do as much simplification as do as much as you can before you get to the calculator. So this is going to be the cosine of 3 pi over 4. If you are radian challenged, that's okay. 3 pi over 4 with some practice is 135 degrees. So the cosine of 135 degrees is negative root 2 over 2. So actually, I got this, frankly, because I've had a lot of practice with my unit circle. But let's practice how you'd plug this into the calculator, okay? So I'm here. How do I do the cosine of 3 pi over 4 in my calculator? Okay, so I'm just going to turn the paper so that the background isn't so confusing. Okay, so it is 23 plus 20 cosine, and then you literally use the pi key on your calculator. So 3, the pi key is above the caret underneath clear. So second caret divided by 4. And there's your answer. And that is indeed the correct answer in the back of the book, 8.86. Let's say you prefer to use degrees. Okay, You don't like 3 pi over 4, the pi part confuses you, whatever, no problem. Go back to mode, adjust from radians to degrees, make sure you push enter, quit out, and this becomes 23 plus 20 times the cosine of 135. Either way, same answer. Which way is better? It makes no difference. Makes absolutely no difference. Okay, and then next video, I will be doing problem 6, the spaceship.